In this video, we'll be looking at what happens when we have two parallel lines. So let's call them L and M. And we know they're parallel because they have those arrows on them. And we're going to look at what happens when we have another line that goes through both of those lines. And that line is called a transversal. So a line that goes through two lines is called a transversal. Two lines at two different points. So let's call that transversal T. Alright, so when that line goes through our two lines, we're going to have 8 angles being formed. The angles 1, 2, 3, 4 are here. And they're called different things. So we looked at them before, but we'll look again. The ones inside are called interior angles. So these are inside L and M, between L and M. And the ones outside, exterior angles, because they're outside L and M. Now, more specifically, some of them have certain names in certain pairs. So for example, let's first look at 1 and 5. So 1 and 5 are on the same side of the transversal, and they're both at the top of their corresponding lines. So those angles are actually called, funny enough, corresponding angles. So there is a rule that if our lines are parallel, so like in this case L and M are parallel, if our lines are parallel, corresponding angles will be congruent. So in this case, 1 is congruent to 5. Alright, we have other corresponding angles here. So on the other side of the transversal, at the top of L and M, we have 2 and 6. They are also congruent because they are corresponding. So 2 and 6. What other angles are corresponding with each other? Well, we have, again, on the left side of the transversal, the other two angles, the ones at the bottom of their corresponding lines, are also corresponding angles. So we have, let's see, I don't know why I wrote that like that. They're not approximately equal, they're corresponding. Alright, so 3 and 7 are also congruent. And the last pair that's congruent because they're corresponding is 4 and 8. So 4 and 8 are congruent to each other because they're corresponding angles. Alright, so let's look at some other angle pairs that we can form. Okay, so we also looked at the term alternate interior angles. Let's remind ourselves of what that term means. So if they're alternate interior angles, they have to be interior angles. So we already know that 3, 4, 5, and 6 are our interior angles. They have to be on opposite sides of the transversal, but they cannot be adjacent. So 3 and 6 are alternate interior angles. And alternate or alternative interior angles are also congruent. So in this case, our alternative interior angles, or alternate for short, interior angles, are, as we know, 3, and it's actually congruent to 6. We also have another pair. What are the other interior angles? Well, if you said 4 and 5, you are correct. 4 and 5 are also congruent because they're alternate interior angles. Okay, so how about alternate exterior angles? Well, we already know that our exterior angles are 1, 2, 7, and 8 because they're outside of L and M. So the alternate portion of that phrase, well, we know that we're looking on opposite sides of the transversal, and we also know that they cannot be adjacent to each other. So our alternate exterior angles are 1 and 8. Let's write that down. Alternate exterior angles are 1, and it's congruent to 8. And we have another pair of alternate exterior angles. So we have 2 here, and on the other side of the transversal and non-adjacent, we have all the way down here 7. So 2 is congruent to 7 because they are alternate or alternative exterior angles. So the final relationship that we're going to look at before we look at an example today is consecutive interior angles. So we already know our interior angles that we should be used to by now. Our interior angles are 3, 4, 5, and 6. And the consecutive interior angles are actually on the same side of the transversal. So we have here 3 and 5. They are consecutive interior angles. So let's write that down. Consecutive interior. All right, so now here is the trick. You've got to remember this. These angles are not congruent to each other. Consecutive interior angles are actually supplementary angles. So 3 and 5 should add up to 180 degrees. And so should, on the other side of the transversal, the interior angles here are 4 and 6. So 4 and 6 should also add up to 180 degrees. So let's write this down. So really the measure of angle 3 plus the measure of angle 5 is 180. And the same goes over here, that the measure of angle 4 and the measure, so plus, that's plus the measure of angle 6, that is one big mess right here, but you get what I'm saying, is equal to 180. So when we add up consecutive interior angles, we get 180. But here's a quick trick that you can use to do questions really, really easy. So here's the quick trick. If you have parallel lines and you have a transversal, and your transversal is clearly making some angles that are big and some angles that are small, well, here's the cool thing. Every small angle will be congruent to every other small angle. And every big angle will be congruent to every big angle. And when you take a big angle and you add a small angle, you will always get 180 degrees when you add the measure. So that's a quick trick, but you still do need to know the terms, alternate interior, consecutive, so on and so forth. But when you are doing a problem quickly, you can, go to this to help you. So by either school of thought, you can realize that that's a big angle and that's also a big angle, so these angles would be congruent. Or you can realize they're both interior and they're alternate interior angles, which would mean they're congruent. So 2x minus 15 is actually going to be equal to x plus 15. 55. There we go. And then we can solve it algebraically, so we can go ahead and add 15 to both sides. And we get that 2x is equal to x plus 70. And final step, we can go ahead and take x from both sides to get that x is equal to 70 degrees. And that's how it works.